What's up you guys, thank you for joining me. Now in today's video we are going to be doing inverse function. So without further ado, let us get started. Now before we start, let me show you what inverse function is all about. Right, let me give you an example. Let's say we have an arrow diagram. Okay, we have 1, 2, 3, here's the object, and then we have 2, 4, 6, here is the image. So they are all connected. Okay, so this forward relationship is the forward function. So let's say the name of this function is called f. Okay, so this is called forward function f. Okay, but there is also a reverse function. That means we are moving backward. Okay, so this is what we call as the inverse of f. Okay, that means it's moving backward. So in other words, the object of function f, right? If I say object 1, it gives me 2. So f1 is equals to 2. f2 is giving me what? What's my image? 4. f3 is equals to 6. Correct? So that's how it's connected. But if I do for inverse function, it's going to look like this. Inverse of 2 is going to get me what? 1. Right? So that's called inverse. Inverse of 4 is going to give me what? The reverse of this is going to give me 2. And the inverse of 6 is going to give me 3. So this is the relationship between forward function and inverse function. Okay, forward function is bringing you from the object on the left here to the image on the right. But inverse function is the reverse process. So the object for inverse is going to be this, the numbers here. Here are the objects for f inverse, and the image of f inverse is this on the left. Okay, so it's the opposite of function f. Alright, so with that, let us go straight to the questions. So question 1. In the arrow diagram on the right, the function f maps x to y. So here is all x, the one on the left is all x, and then the one on the right is all y. So they ask you to find what? Find f4. So number 1, A, f4. So this is the forward function, so you just have to follow the flow of f. So this is what? The object. So when object is 4, what do I get? My image is -5. B, f inverse -1. Okay, -1. Let me just write it. Okay, so f inverse -1. So now we are seeing the backward. We are seeing backward from left, from right to left. Why? Because this is inverse f. Okay, inverse of f. So now the -1 is the object. So the object is supposed to be this. Okay, it's supposed to be on the right. Okay, because now we are reversing the process. So the object of f inverse is going to be the one on the right. So now -1 is connected where? It's connected to 6. So 6 is the image for f inverse function. Okay, let's look at C. F inverse 2. So where is 2? 2 is here. So when the object of f inverse is 2, what do I get? The image is -2. Okay, D. F inverse -5. So when f inverse -5 is here, it's connected to 4. So you see that these two, they are actually opposite. Correct? So that's the relationship, forward function and inverse function. Okay, alright, next. So the function g and h are defined by gx equals to 5 over 2 minus x and hx equals to 3x plus 6. Find A, g12. So what is g12? G12, they already gave you the function gx, correct? So if you want to find g12, that means the object is 12. So you just have to substitute 12 into the equation. So 5, 2 minus 12. The x value becomes 12. So 5 over -10. So your answer is -1 over 2. Okay. Now B. Now this is a tricky question. If you understand the concept of inverse function, then you will understand this very well. So I give you an example. Arrow diagram, here 1, is connected to 2. Let's say this f, and then the reverse process here is called f inverse. Okay, so now here's what I want you to understand. I told you just now, f, when the object is 1, I get 2, correct? But if I take f inverse 2, I get 1, correct? So what can you understand from this? What you can understand is that the object for f is actually the same as the image of f inverse. Okay, so the object of f is actually the same as the image of f inverse. Okay, understand this. And on top of that, the image of f is actually the same as the object of f inverse. Okay, so looking at this question, they're asking you what is G inverse 4. So this G inverse 4, the object is supposed to be the same as the image of gx, correct? The image of gx. So this is going to be the same, and this too is going to be the same. Okay, so because of that, you can actually do this. Gx equals to 4. Get it? Gx equals to 4. Why? Because they are telling you the object, so this is the object of G inverse is going to be the same as the image of G. Correct? So this is the image of Gx. So in other words, how you can solve this is by using this equation. Gx equals to 4. So it's going to look like this. Gx equals to 4. Okay? So it's okay. Let me rewrite this so that you can understand better. So it's going to look like this. G inverse 4 is actually equals to this thing. It means Gx is equals to 4. Okay, so this is the object of G inverse, and this is the image of Gx. Okay, that because they are the same based on what I explained here. Okay, so now we're just going to substitute the equation. So 5 over 2 minus x is equals to 4. So 5 is equals to, you bring this whole thing up there, it's going to be 4 times 2, 8 minus 4x. So 4x is equals to 8 minus 5, x is equals to 3 over 4. So this is your answer. Now if you don't understand what I'm saying, don't worry, okay? We have a lot more examples that we're going to go through. So let's be patient and go through the questions. So for now, C. H minus 1. So this is the object, correct? Minus 1 is the object. So now you have the hx function. So what you have to do, just substitute negative 1 into the x value. So you get negative 3 plus 6. So the answer is 3. Okay, so now D. Question D, they're asking you for h inverse of 9. So now they give you the object of h inverse. So it's going to be the same as the image of h function. So in this case, the image of h function is what? Hx equals to 9. So hx is 3x plus 6 equals to 9. 3x equals to 9 minus 6, you get 3, x equals to 1. Alright, now next. Determine whether each of the following function given has an inverse function. Alright, so now we're going to learn about the properties of inverse function. So here's what I want you to know. Here are some properties that you should really understand, right? So for it to be an inverse function, it has to fulfill a few conditions. The first condition is that it has to be a one-to-one relation. What does this mean? That means one object can only have one image. Okay? One-to-one relation. It cannot be one to many or many to one or many to many. No, you cannot. It has to be one object has one image. So if I have an arrow diagram, okay, let's say I got 1, 2, 3, and I got 2, 4, 6. All these objects can only have one image. if you see that, for example, 3 is connected to 4 and 1 is also connected to 4, therefore this is not a one-to-one function. Why? Because many to one. 2 of this number has one image, which is 4. So many to one. It has to fulfill one-to-one condition. That means one number, one object, connect to one image. That's it. Okay, so that's the first condition. The second condition you can use to solve graph especially is this thing called the horizontal line test. Okay, so if you followed me on the first subtopic, I actually talked about vertical line test, right? So if let's say I got a graph, okay, let's say I got a graph, I use vertical line, okay, let's say I draw a vertical line here. So if it cuts one point, it means it fulfills the one-to-one relation. One object has one image, so therefore this line is a function. Okay, but now you want to determine inverse function, correct? So inverse function you have to use this thing called horizontal line test, is where you will draw a horizontal line. So let's say you draw a horizontal line here. You notice that it only cuts one point, right? So because it only cuts one point, you can say it has an inverse function. Okay, because it fulfills the one-to-one relation. However, if let's say you get a graph like this, okay, let's say, and you draw a horizontal line, it's going to cut through 2 points, correct? You have two objects, so therefore it doesn't have, it does not fulfill the one-to-one relation, okay, because you have multiple objects now. Okay, so for it, remember, for it to have an inverse function, it has to fulfill the horizontal line test. So coming back to our question, determine whether each of the following function given has an inverse function. So let's look at A. So the question is asking whether it has an inverse function. So does it fulfill the one-to-one relation? So you notice that 1 is connected to 8, 2 is connected to 5, 3 is connected to 4, 6 is connected to 8. So all of these objects here only have one image. So therefore, it is an inverse function. Why? Because it fulfills the one-to-one relation. What about B? X gx. Okay, so negative 4 is connected to 13, 3 is connected to 6. However, you notice 4 is also connected to 13. So therefore, this is not an inverse. It does not have an inverse function. Why? Because it does not fulfill the one-to-one relation. Right? Let's look at C. So C here, you notice it's a graph, correct? So we can use the horizontal line test. So if let's say I draw a horizontal line, notice that I'm cutting 2 points, 1 point here and 1 point here. So in other words, I have two objects. So this graph does not have an inverse function because it cuts through 2 points, therefore it has two objects. So it does not fulfill the one-to-one relation. Okay, so it's not. Now let's look at D. Now D here is actually telling you the coordinates, right? The coordinates. So this is the X, this is the Y, this is the X, this is the Y, this is the X, this is the Y, this is the X, this is the Y. So from here actually you can draw an arrow diagram. If you want to, you can draw an arrow diagram. So I'm going to show you guys. So you got see all the objects here are 1, 4, 5 and 9. 1, 4, 5 and 9, and they are connected to 2, 5, 8, 9. 2, 5, 8, 9. So all of them are only connected to each of the images there. So one object has one image. So therefore it has an inverse function because it is a one-to-one relation. Okay, now F. So they gave you an equation here, fx equals to 4 minus x squared. So from here, by now you should already know what this graph look like. Okay, if I draw this graph, it's going to be See, it's a negative quadratic graph, correct? So quadratic graph can only be a U shape or an N shape. Okay, since it is a negative, so it's going to be an N shape. So what is the intercept? The intercept is at 4. So you draw a graph here. Sorry. Okay, so here is 4. Okay, so now what am I going to test? I'm going to use the horizontal line test. So if I draw a horizontal line here, I'm cutting 2 points, correct? So is this a function? Answer is no. It is not. It does not have an inverse function. Okay, because it's not a one-to-one relation. Right, next. Are the following function f and g the inverse functions of each other? Verify the truth by applying the relation f(gx) equals to g f(x) equals to x. Now let me tell you something. If I have a function, okay, let's say this is a function, and I have another inverse function. Here's what I want you to know. If I combine these two, f and f inverse, or if I do this, f inverse and f, okay, let's say I combine them, your answer should be x. It is guaranteed. Okay, that is why when we did the composite function, I showed you guys why we can neutralize, correct? I showed you guys how to neutralize. If you want to find gx, you just add the f inverse x, you neutralize this, it becomes gx. Okay, so that's what I'm trying to tell you. So f and f inverse, it gives you x, or f inverse and f, it gives you x. So from this question, right, what they're asking is, are the following function g, f and g the inverse of each other? So if they are, if let's say f is the inverse of g, so you can say that gf or fg will give you the answer x. That is why they ask you to fulfill this. You have to check whether it fulfills this condition. If it fulfills, that means fx and gx are actually inverse of each other. Alright, so let us check. So the first part, a, fx, so let's find fg first. Okay, fgx. So you're going to substitute gx as the object for f. So you get 3x minus 2. So now instead of using x, you're going to substitute the gx. Okay, so x plus 2 over 3. Okay, so that's how you're actually substituting gx. So what do you get? So 3 and 3 you can cut. So x plus 2 minus 2 equals to x. Alright, so this first condition is fulfilled. Let's look at the second, g fx. Do I also get x? So first thing you want to know, substitute fx as the object of gx. So gx is what? X plus 2 over 3. But you cannot use x. You have to put in the value of fx, which is 3x minus 2. Okay, why? Because this is the object. So now, so you get 3x minus 2 plus 2 is actually 0. So you divide by 3. Answer is x. So since fg is equals to gf is equals to x, therefore you can say that it fulfills the condition. So therefore they are inverse of each other. Okay, now let's look at b. Let's do the first part, fgx. So what is fx? Fx is 2x. Okay, this one need more space. Over x minus 3. But now you're going to substitute the x value, you're going to substitute as gx. Why? Because gx now is the object. So you get 3x over x minus 2, and here also 3x over x minus 2. Now this is much more complex, but it's okay. So you get 6x over x minus 2, and then here you're gonna get 3x minus 3 x minus 2 over x minus 2. Okay, so what do you get? 6x over x minus 2 times x minus 2 over 3x minus 3x plus 6. Okay, so here you can cut. So you get 6x over, here you can minus, so over 6. Answer is x. Okay, so this one is correct. Now let's see g of x. So what is gx? Gx is 3x over x minus 2. So now you're going to substitute the fx, because it's the object, right? So you're going to substitute fx into the x value. 2x over x minus 3. Okay, so same thing, 3 times 2, 6x over x minus 3. Now in case you don't know what I'm doing, right, I'm actually changing this. Okay, since it's a whole number, I'm going to change this to make it the same denominator. So here x minus 3, so here I have to multiply x minus 3. Okay, so that's what I was actually doing. Okay, so what do I get? I'm getting 2x. Since they have the same denominator, I can actually put them together. So 2x minus 3 over x minus 3. So I get 6x over x minus 3 times, now I'm going to bring this the opposite to the front, to the back. So it's going to be times x minus 3 over 2x minus 2x plus 6. So same thing, I can simplify here. You can minus this, so you get 6x over 6. Answer is x. So you can say that it does fulfill the condition. So f gx is equals to g f x and is equals to x. So therefore the two functions f and g are inverse functions of each other. Alright, next.